So the topics we discuss in this video will have these prerequisites. You should check them out if you have no idea what these things mean. Like you should have basic idea of JS arrays. If you have never used array functions before, you should check out what array functions are, and also comparison operators is a basic thing you should know. JS objects, because we are going to use JS objects in this video. So first function we'll talk about is filter. uh, what filter will do is it will just select certain elements from the array. So what happens is you give all elements of array, you pass all elements of array through a filter. Now the output will be some elements of array, or those elements of array which pass the filter. So uh, it is just like selection operator, you can say. Let's try this filter on simple data. Here simple data is an array containing numbers. What if we only want negative numbers from an array of numbers? Visually we can see that there are only these negative numbers here, but actual practical applications the actual data can be very long. So it is better to just write a filter on that array. So what we can do is const negative data is equal to simple data dot filter. For each element, selection is when element is less than 0. Console.log neg data. This should get us just the negative numbers. Yep, it only gets the negative numbers. That is what we want. So here you can see that filter will take a selector function, sort of. This function will return, if this function returns true for an element, then that element is selected. If this function returns false for that element, then that element is not selected. Here only -19, -44 and -20 gave true for this expression of the number being less than 0. Now let's see, a more complicated example will be on this data array. I've put this data in a separate file to make the code cleaner. This data array is an array of objects. As you can see, each object is guaranteed to have these 5 properties: name, age, gender, monthly plan and location. So the filter that we want is get adult users of the platform. So it is just user data. Let's rename it user data. From the user data we only want users who are adults. So for each element we only want those elements that have age property set to number greater than or equal to 18. Very straightforward thing. Const adult data is equal to user data dot filter. For each user dot age should be greater than or equal to 18. Console.log adult, let's just say adults. Let's compare this output with actual data. In actual data we had Amit Patel with age 17, Priya Sharma age 28, Sneha Reddy with age 16. In our output we can see that Amit Patel has been skipped. We got Priya Sharma first, then Sneha Reddy got skipped, we got Rajesh Kumar second. So we have effectively selected only adult users on the platform. So this is filter function. It is just a selection function. What it does is to summarize, filter function takes, okay, the function itself is taking a function. It is a bit weird to write this, but okay, we'll just write this. Takes a function that takes an element as argument, and we can either return true or false to select or reject that element in our output. Yeah, this is nice description. This is a good summary for what we have discussed about it. Now the next function will be map. In map, what we do is we get array of similar size in the end, not just similar but exact same size in the end, but each element will go through a transformation process. So if filter was for selection, then map is for transformation. What do we select here? Here we select a subset of elements. Here we transform all of the elements. So let's say our input data is this array, and we want to transform every element to get square of that element. That is, we can write const squares is equal to simple data dot map e into e. Let's print it. Console.log squares. Let's remove this clutter output. Let's check. 64 is square of 8. I can say from memory that it is true. Minus 19 square is 361. 7 square is 49. So we have squared every element of this array using map. So as you can see, we can just write a function to write logic for how each element should be transformed, and we can pass this transformation function. Here it is in the form of array function to map over this array. Now we will do something more interesting than this. This is just a textbook example, but what we can do now is we will for this given data we will devise, I should not say device, we will just write a simple logic to get first name and last name of every user. So get first name and last name of each name of each user. Name of each user. Get first and last name of each user. So here you can see the problem statement itself suggests that this is a transformation operation. For each user we have to get first name and last name. That is a transformation operation, and how we can do that is full names is equal to user data dot map. For each user we have to return an object. Okay, return an object with first name being user dot name dot split with space and get the first part, last name being username split with space and get second part. Why is it showing red color? Okay. We can't directly return objects like this because in array function when we use curly braces it thinks that it is function body. So in function body we have used colon out of nowhere and we have put comma out of nowhere. We have to wrap this inside an object. Let's see. So we have got what we wanted. Here we have took this object and transformed this object into this object. And this is what we wanted. We wanted first name and last name of every user. So first name of first user is Amit and last name of this user is Patel. We are done with maps. Now we will use reduce. Okay, what is reduce? What reduce does is that it combines all of the elements of the array to get a single value. So one simple textbook example is we have an array of numbers and we have to add all of these numbers. Okay, one interesting thing that reduce one interesting way in which reduce is different from map and filter is that it takes a second argument and that is like an initializer for an accumulator. How reduce works is it goes over elements one by one. It takes an initial value for accumulator, and while it goes over elements one by one, for each element it will add some changes to accumulator. So in our example of sum of all numbers, what we'll do is we will first pass 0 as accumulator, then we will also pass a function which will take each element. So what the function will do is add that element to accumulator. I should just directly write the code, that will be better. So const sum of nums is equal to simple data what our function will take element and accumulator and return element plus accumulator. Initially accumulator is 0. Okay, because addition is commutative, here the order of A and E does not matter, but I think I should recheck if accumulator is first or second, because in more complicated examples the answer will be wrong if here we have taken wrong order. So if array.prototype.reduce, okay, callback first takes the accumulator, then it takes the element. So you see the difference here. Oh wait, reduce. So you see the difference here. In map we just gave a function which will take an element and transform it. But in reduce, we give a function which not just takes the element but also running value of accumulator. It, and it will also take initial value of accumulator. So the reduce function itself just takes initial value and passes the passed arrow function the running value of accumulator after uh, when it reaches every new element. So what it will do is our array was this. So the first iteration will have accumulator 0 because initial value is 0 and element as 8, and it will return 0 plus 8 which is 8. Then the second element will receive accumulator value 8 and the element itself is 19. Addition of 8 and minus 19 is minus 11. Then we have accumulator minus 11 passed with element 7. So you see how this works. For this we can reduce it, I think. It doesn't matter, we'll just get the output. We'll remove the previous clutter. So sum of all values was 36. Should we verify it? We can. 8 plus minus 19. 8 minus. Yep, 36. This was a very simple application of reduce, but we can do something much more interesting. Like let's say our initial value for accumulator is this object with basic key mapped to 0, standard key mapped to 0, premium 0. So I should clearly say what it is. In data, in every user's information we have this monthly plan thing. So they are using our service with certain monthly plan. There are 4 types of monthly plan: basic, premium, standard and enterprise. Yeah, he got the enterprise. 50 years old, checks out. So let's say we want to get count of how many people are on basic plan, how many are on standard, how many are on premium and enterprise. So what we have is input is an array of objects and output is just a single object. It is a reduce operation, and in this reduce operation initially all of the frequencies will be 0, but every time we encounter basic we will increment the frequency of basic by 1. So what will happen is, it is a very simple reduce application. Const const stats is equal to user data dot reduce accumulator user function body return. Let's see, it can just return same accumulator user dot monthly plan. So if user dot monthly plan is basic, the key basic will get touched inside accumulator and it will be incremented. Then we can just return accumulator itself, the modified accumulator. Okay, initial value of accumulator was this. Let's now check the stats. Okay, so there are 3 users under basic monthly plan, 2 under standard, 4 under premium, 1 under enterprise. Let's check for basic. 1 2 3. Yep, 3. Standard 1 2. Premium where 1 2 3 4, and enterprise is only 1, the 50-year-old. Okay, these were the sort of the most difficult of these 5. So if these 3 felt easy for you, the next 2 is very simple. Okay, the next 2 are sum and every. They are literally what they sound. If there is some element that the function selects, then it returns true. If none of the element is selected by that function, then it returns false. What I mean is that it is somewhat related to filter, but in filter, okay, let's check. In filter, where is it? Here it is. In filter, we return a true or false value. If the return value is true, the element is included in output. If it is false, it is not included in output. In sum, we pass a similar function which will either return true or it will return false. But what sum function is for is that it checks if any of the element of the array matches some condition, and in the end, if even at least one of the element matches that condition, then the whole expression becomes true or false. So output is not any array. Like in filter, we had array output, subset of elements. In map, we had array output, same size array. In reduce, we had a any value output, collapse to one value, collapse input to one value. The value can be also an object, not just a primitive, just like what we saw with this one. We had an object storing frequency. Now what sum does is it will return either true or false. Same with every. So it will only have Boolean output. It will become clear with examples. Let's say we want to know if our array has any negative number. We can check that with if simple data dot sum. Some element of it is negative. If some element of is negative, then this expression will become true. We can do console.log. Yes, there are negative numbers. Console.log. No negativity. let's remove this clutter. Let's see what should be the expected output here. Our array contains both positive and negative values. Okay, here some will first encounter the value 8. The 8 is not less than 0, so it will just pass. It will then encounter value minus 19. Minus 19 is indeed less than 0, so the sum function halts here. It decides the output is true, and we get the output, yes, there are negative numbers. Yes, there are negative numbers. Actually, one interesting thing that we can do is we can trace the output. Simple data.sum console.log e, return e is less than 0. You see what I am doing here is I am checking for which values of e this sum function runs, and we can verify where this check stops and the function finally decides what the end value should be, true or false. Here you can see we ran a check for 8, but the function was not decided here because it did not find negative number. Then we ran a check for minus 19. We did find a negative number, so it then just returns true and we get our output. So in some way, what sum is that it halts on first truth. Let's summarize it. Halt on first truth encountered and return true. If no truth was encountered, just return false. That is just fancy way of saying if any element matches our condition, return true. Our if any element, it should be better worded. If any element matches, yeah, it can be written like this. But if no element, okay, passes our check, passes our check will be better. If no element passes our check, return false. Let's see. Is there any perfect square? If simple data.sum, let's just copy this one. So here I am getting square root of e and just removing the decimal part of it. It is just math part. And if the square root had no decimal value, I mean if the square root didn't have any decimal part, then the number must be able to be reproduced this way. And if the number can be reproduced this way, then the number is perfect square. See here, none of these values were perfect squares, and it is easy to verify that between 1 and 100 there are like only 10 perfect squares. I think those perfect squares are 1, 4, then 9, 16, 25, 36, 49, 77, then 64, 81 and 100. All of these numbers are between 1 and 100, and none of these numbers appear here, so there is no perfect squares in this array. But we can just add some perfect square. Let's rerun this. Here you can see the execution stops near 64 and we get yes, there is a perfect square. Okay, let's do the next one without writing any logs, because now we already know how sum works. We'll just write directly the condition in arrow function without any function body. Oh wait, this is an example for every. We have to check if every number is under 100. Okay, we can also transform it as an example for is there any number equal or above 100. Okay, this becomes an example for sum now. Nice. Okay, console.log found a century, else no centuries. No centuries, yes. None of the numbers cross 100 or touch 100, so there are no centuries in this array. Now, okay, we have looked what sum does. To summarize, I think we have summarized it. Yeah, we have summarized it. What sum does is it goes over every element, and if any element passes the check, it just returns true. If none of the elements passes our check, then it returns false. What every does is it checks, it will only return true if all of the elements in our array pass the check. If even a single element in our array fails the check, then it will just return false. If you have studied Boolean operators, sum is just OR operator and every is AND operator. This should make it even more clear for you. So let's just directly use every here. Are all numbers under 100? This is just inverse condition for this one, but let's write using every. Simple data.sum. Wait, every e is less than 100. All double what should we write? There is no catchy phrase. All are less than 100. Some big guns. All are less than 100. Okay. Let's add something. Let's add 196. What does it say now? Some big guns. Yeah, it found a big gun. If simple data dot every are all numbers not perfect square. Okay. This will be a bit big. We have to get int square root, which is mat.floor mat.square root of e. return int square root into int square root is not equal to a. Only if all of the numbers are not perfect square, we are all imperfect, wait, okay, this is correct. Some are too good. Let's see. There are no perfect squares, I think. Yes, there are no perfect squares. So we are all imperfect. Let's see. Yep, we are all imperfect. Let's add some perfect square. Some are too good. Yeah, this one is too good. Let's remove this good person. Now no one's good. Okay, these were very simple examples. I think you should try these by yourself because some and every are very basic functions. So yeah, try these by yourself on this more complicated data. Okay, maybe I'll just do this one. Is there any minor premium user? So we have to check if any element here has an age less than 18 and a monthly plan of premium. We'll just do exactly that. In user data, do we have some user where user's age is less than 18, he is a minor, and user dot monthly plan is premium. If there is such user, okay, I'll put this. We got some rich kids in lobby. Else what? Else no minor premium user. Rich kids in lobby. Who is the rich kid? Let's see. Okay, what we can do is let's just see in data. 17. Okay, the first kid itself is rich kid. He is a minor and he got a premium plan. Okay, so this is it. Try doing these two yourself. Let's see, is there any enterprise using our service? So we just have to check if any user got monthly plan of enterprise. Are all users under age 60? So we have to use every function, and in every function, I mean literally the function named every, we have to use the function every, and in it the check will be user dot age is less than 60. Yes, that is simple. So this is it. These are the functions: filter, map, reduce, sum, and every. That's it.